So this is Theorem 1.1, our theorem which tells us the criteria or the criterion so that the limit of a function exists as x approaches a. But this one is quite a cumbersome way to know what is the limit of a function, because we must pay attention to the one-sided limits of your function as x approaches a. These theorems will help us easily get the limit of functions. So, limit theorems. Suppose the limit of f as x approaches a and the limit of g of x as x approaches a exist and c is a constant. The following rules apply. The limit of c as x approaches a is equal to c. Now, why is that so? Well, you can look at c as a constant function. F of x is equal to c. Suppose, for example, our c here is 1.5. So what is the limit of 1.5 when x approaches 2, for example? So what we do using the Theorem 1.1, our theorem for the existence of limit, we will look for the limit of our function as x approaches 2 from the left, okay? And it's equal to 1.5. In the same way, when x approaches 2 from the right, the limit is also 1.5. The limit of x as x approaches a is equal to a. So this is like x is the linear function, f of x is equal to x. So let's say, for example, our a is equal to 1. As x approaches 1 from the left, our function approaches 1. When x approaches 1 from the right, our graph approaches that point, and the value of our function is also 1. So the limit of x as x approaches a is just equal to a. The limit of c times f of x as x approaches a is equal to c times the limit of f of x as x approaches a. So for example, our function, our c times f of x is this one, negative 2 times x. So negative 2 is our c and f of x, okay, f of x is equal to x. So what then is the limit of this function when x approaches negative 1, for example? So when x approaches negative 1, we will pay attention to this part of our graph. It approaches that point. When x approaches negative 1 from the right, our graph also approaches that point. And the value of our function there is equal to that. It's equal to 2. And it is the same as c times f of x. Our c here is negative 2. F of x is equal to x. And so the limit of negative 2 times x as x approaches negative 1 is just equal to negative 2. Okay? It's like we are factoring out c is equal to negative 2 times the limit of x as x approaches negative 1, which is just equal to negative 1. And it is equal to 2. If r is a positive integer, the limit of f of x raised to r as x approaches a is equal to the limit of f of x as x approaches a, all of that raised to r. So this is telling us that if the limit of f of x as x approaches a is equal to L, then the limit of f of x raised to r when x approaches a is equal to L raised to r. So let's say, for example, we have this. So our f of x is equal to x. And so x squared is just f of x raised to 2. So 2 is our r. So in this case, the limit of x squared as x approaches negative 2 is equal to the limit of x as x approaches negative 2, all of that raised to 2. Now what is this? That is just equal to negative 2. Negative 2, so the limit of the whole thing is negative 2 raised to 2, which is equal to 4. The limit of f of x plus or minus g of x as x approaches a is equal to this. It's equal to the sum of the limits of our functions. And you know what? This is telling you something. This is telling you something, and you will know what this theorems is all about. When we have a function such as this, okay, so this is our f of x, this is our operation, and this is our g of x, all we have to do is to find the limits of those terms or of those functions. And what is this? What is the limit of x squared as x approaches negative 2? It's equal to negative 2 raised to 2. What is the limit of 2 times x as x approaches negative 2? It's equal to 2 times negative 2. And this is equal to 8. This one is equal to 4. And negative 2 times negative 2 is, this becomes plus 4. So what is this telling you? Well, this is telling you that the limit of a polynomial function, okay? So if your function is a polynomial function, such as this one, if you are evaluating the limit of this polynomial function as x approaches negative 2, all you have to do is to evaluate what is f of negative 2, okay? So this whole thing here is your f of x. So what is the limit of that function as x approaches negative 2? This is what you have to do. You just evaluate what is f of negative 2. This is true for polynomial functions.